Machine learning is utilizing large amounts of data in order to draw insights that a human being might have difficulty drawing.
I guess on just a very high level, it's the process of trying to extract patterns from some data.
At the end of the day, what you're trying to do with machine learning is you're trying to use pretty advanced math to effectively look for patterns in data.
You want to understand the data better, and specifically you want to make predictions with the data.
This is then when you start getting insights where you typically wouldn't have been able to see this because you can't see the forest for the trees.
So machine learning goes beyond what we just call descriptive analytics. Look at what has happened in the past and you report it. So predictive analytics is taking this past data and looking at new data input points and then predict what would be the correlation of that data point in terms of the outcomes. Predictive analytics predicts the future, what is likely to happen. But what can you do about it? So from descriptive analytics to predictive analytics to prescriptive analytics.
I'll use an analogy. The mechanical industrial revolution that happened, let's say about 100 to 150 years ago, essentially what we did is we took mankind's muscles and we outsourced them to machines. What the goal of machine learning is today is to do the exact same thing, but we want to outsource lower level decision-making tasks with potential to eventually replace, I suppose, to some people, all decision-making.
I would say that machine learning is about learning from data how key characteristics or features are related to some or other objective. The objective can be something concrete like recognizing a face or translating a sentence from Spanish to English. Sometimes the objective is less well-defined. So in that case, you would, for example, just want to cluster items into groups that are similar. So you need to define what similar means. And again, that depends on why you are doing the clustering.
Supervised learning is where you're basically giving it examples and telling it, like, learn from these examples. So supervised learning has been the most successful because big companies could actually muster the resources to get people to label data and give examples. That's one of the reasons why image recognition, that's been very successful. Where unsupervised learning is actually significantly more difficult because you don't have examples. You're trying to find these examples.
You find trends in data or clusters or think segmentation.
Reinforcement learning is like an agent approach to the problem.
That is really also a case where you typically have an agent that should do some actions.
By agent, I mean like a little program. The agent is effectively looking at the environment and then using the data that it senses to basically continuously learn and try and be better.
And then you learn it by giving the agent certain rewards if it's behaving good, and some penalties if it's behaving bad.
So the reinforcement comes in where you effectively go and say, I did something well here, so I'm going to keep on doing this, or I did something poor here, so I'm going to, basically punish myself and not do this anymore.
Once you've learned in this agents can make then actions and decisions on your behalf and will do it according to these good and bad metrics. If you look at machine learning, you can get two types of machine learning. That's the batch learning, where I give you all the data now. Then you get so-called online machine learning models, where the data is trickling in, and as the data comes in, you actually update your model and relearn it. When you start using this model, there you have two cases. The one would be batch scoring, or a batch use of the data, and the other one would be then in a streaming sense. So it's best to explain it by examples. A batch case example would be, I want to do a marketing campaign and I want to know to who should I send a SMS, for example. So with batch scoring is I will take all the data, a batch of data, and I will calculate in other words, score for each person, whether they should get an SMS or not. The streaming setting would then be, for example, transactions, and I have to decide whether the transaction is fraudulent or non-fraudulent. So then I can't wait every night to have all the transactions in one pot. That would be a batch setting. I have to do them as it happens. And in those cases, it's a streaming scenario, and then I score them as they arrive with me.
I'd say that's more or less the spirit of machine learning, using data to find trends that you would not be able to find just through inspection.
So I would say machine learning is really about exploiting those associations in the data and then mapping those inputs to the outputs.